All right, guys, so today we are starting chapter 2.1, or chapter 2.
Is that the mic for you recording? You're saying, I thought it was.
Yes, so it records it for me. What we're starting is, this chapter is reasoning and proof. So a lot of it's going to be dealing with statements, and if you notice from the vocab that we did yesterday, a lot of it was very, not so much mathematical based as chapter 1, where we talked about angles and measures and actually these things here. And it's a lot about, it is worded. And a lot of math, when we prove something, either true or false, we use statements. And we want to use these statements to be able to show it. So what we're starting off today with is conditional statements. A conditional statement will be used to prove something being true or false. So a conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. When a conditional statement is written in if-then form, if part contains the hypothesis and the then part contains the conclusion. So really, a conditional statement contains two parts, a hypothesis and a conclusion. So really, that's all that is saying, is a conditional statement contains a hypothesis and conclusion. And we can write it in if, P, then Q. If the hypothesis, then the conclusion. Or we can say P implies Q. You
have something recording while you're doing this? See that thing up there? Not recording, like videoing while you're doing this? No.
Not an actual video, but it's recording everything on the screen. Yep. So are there any questions on this so far? Okay. Let's actually start this off with this first example here. All birds have feathers. So I'm going to underline and circle because y'all just have pencils. We don't have blue and red ink. But we want to circle, so underline the hypothesis, and we're going to circle the conclusion of all birds have feathers. So the hypothesis would be all birds, and the conclusion would be that they have feathers. Because all birds have feathers. The hypothesis, we're talking about birds. The conclusion is have feathers. Now, if we write it in an if-then form, this one here, we're going to have to change the wording a little bit. Because what are we talking about? Birds and feathers, right? So if it is a what? If it is a bird, then it will have feathers. If it is a bird, then it will have feathers. So this really, if then, is put it in a way that we can prove it's a true or false statement. Because if it is a bird, if that is true, then will it have feathers? So we have this true-false statement that we can make. Any questions on this so far? Let's look at the next one. You are in Texas if you are in Houston. So what's the hypothesis? You are in Houston. The conclusion is? What kind of gave it away? If you were in Houston, kind of gave it away what was going to be the hypothesis. So this one here really doesn't need any changing. If you're in Houston, then you're in Texas. And we know that is a true statement. Because if you are in Houston, then you are in Texas. Well, unless you're in another Houston.
Is there another Houston?
There might be. But I mean, will it go the other direction?
No.
Because could we say that if you are in Texas, then you are in Houston? Is that a true statement?
No, because you could be anywhere in Texas, not just Houston.
Yeah. Because it'd be the same as if we said if you're in Oklahoma, then you're in Concord. It just doesn't work that way. But it does work this way.
If you would be in Concord, you somewhere in Oklahoma.
Questions on this here? All angles, all 30-degree angles are acute angles. So what's the hypothesis?
If 30-degree angle,
Let's do hypothesis conclusion first. So we have this, yes? So all 30-degree angles would be the hypothesis, and R acute is the conclusion. Now, I heard some of y'all already start the if-then statement. So if what?
If it is a 30-degree angle.
Yes. If it is a 30-degree angle, then it is acute. Do we have to say acute angle? No, because structurally of the sentence, we understand that we're talking about an angle. Questions on this here? Equals -3. 2x plus 7 equals 1 because x is equal to -3. What's our hypothesis? And the conclusion, or bless you. So our if-then statement would be what? If and that's it. Questions on this here? Yep. X is greater than 5 if x is greater than 3. So our hypothesis would be?
X is greater than 5.
So the way that's because of the if, it's going to make x greater than 3, the hypothesis, and the conclusion is going to be x is greater than 5. Yeah, we'll write the if then, and then I'll explain a little bit. If
It'd be the other way, wouldn't it?
it would make more sense the other way, but this is how it's set up. Because of how it's set up, if x is greater than 3, they told us that, then
But it could still be 4.
yeah. So it's not necessarily true for every number, but it is how this is set up. Because I looked at this morning, I didn't like it. Because I'd rather have it the other way.
That's what
Because it would be true always the other way.
If we was to put it the other way, would it be wrong? Like on a...
If, because of the if, it's telling us that x is greater than 3 is the hypothesis.
So it would be wrong.
Yeah. But we can say it's false. Because if we talked about the trueness or falseness of it, this is false because we can show one case where it is false. Because whenever we try to prove something true or false, we only need one case for it to be false. We only need one example to prove something's false.
Is this section going to be the same the whole time?
Do we need to see another example?
Yes, this one.
Okay, we can look at this one. Would be the hypothesis. And have practice today would be the conclusion. Now, if you play, yes, on the soccer team, then you have practice today. So, I mean, there's different ways we could phrase it. If you're on the soccer team, if you play on the soccer team, then you have practice today. Because we need to signify or some way to show that they're a part of the soccer team. Because if we just say, if members of the soccer team, that just doesn't sound right. It just sounds a little awkward. So we have to rephrase it a little bit to specify that they're not on any other sports team or someone who doesn't play any sports. Any questions on this here? Negations. These here are normally y'all's favorite one of this lesson. The negation of a statement is the opposite of the original statement. To write the negation of a statement, you write the negation symbol before the letter, so not P. It is written as not P. So it can have different meanings. It's a tilde, I think. Yeah, it's a little bit different. So a little bit different. So this is not P. So when we talk about the negation, we're talking about the opposite of the statement. Okay. The ball is red. What is the negation of this? That's it. Now, it's not saying that the ball is blue or the ball is green for the statement because it's just the opposite. Mm-hmm. So the cat is not black. Its negation would be? Mm-hmm. The cat is black. That's it. That is the negation. Questions on this here? Yes. Let's look at these two here. The first one, the car is white. Its negation is? Yes. So it is not snowing. Its negation is?
It's like second grade math.
Questions on this here?
You keep doing this stuff, I will pass your class.
Are we good with this here? Okay. Now, we do have some other related statements because our conditional statement was if P, then Q. P implies Q. We also have the converse. Converse. To write the converse of a conditional statement, exchange the hypothesis and the conclusion. If Q, then P. Yes.
That sucker has feathers. It's a bird. Nice. Well, English can't fly. Neither can chickens can fly.
But an ostrich cannot. So, guys, so the converse, we got this down. Converse is flipping. Now, guys, probably not, but I don't know. Inverse, guys. So we have 4 total. We have the conditional statement, the converse, which is just flipping the hypothesis and conclusion. The inverse is the negation of the conditional statement. Inverse is not P implies not Q. So we negate both the hypothesis and the conclusion. And the contrapositive positive is not Q implies not P. So we have these here. Why don't we go on and look at an example of this?
Question.
Yes.
You're smart. How do you classify a bird? Like, how does an animal classify as a
It'd
bird?
be talking about the genus and the species in the familia. Guys, let's focus in here. So we're going to write these 4 statements and then classify it as whether being true or false. So our first statement is we're dealing with let P be you are a guitar player and let Q be you are a musician. Write each statement in words, then decide whether it's true or false. So we're going to write all 4 out. So the conditional statement, P implies Q. So if, so P is what? If you're a guitar player, then you're a musician. Yes. So we're going to write all 4 out and then do the true and false. So the first one, if you're a guitar player, then you're a musician. So that was the conditional statement. The converse would be what? If you're a, I'll move out of the way here in a second, musician, then you're a guitar player. So we have the conditional and the converse. Any questions about the conditional or converse so far? Because the converse is just flipping. Now the inverse is the same as the conditional statement, but we negate both. Yes, if you're not a guitar player, then you're not a musician. And the last one is the contrapositive. Yes. Not So our 2 statements were guitar player, if you're a guitar player and you are a musician. So our original statement was if you're a guitar player, then you're a musician. Our converse, if you're a musician, then you are a guitar player. So we flipped them. Yes. The inverse was if you're not a guitar player, then you're not a musician. And the contrapositive, if you're not a musician, then you're not a guitar player. So really, we just wrote the statement, flipped it, negated the first, and then flipped it. Yes? So let's go back and look at the truth values, if it is true or if it is false. So our original conditional statement, if you are a guitar player, then you're a musician. Is that true or false? True. Guitar players are musicians, yes? So this would be true. The converse, if you're a musician, then you're a guitar player. No? Are there other, can musicians be other things than guitar players? They can play the trumpet, they can play the drums. I mean, there's all sorts of different instruments. So it's not necessarily the case that Just because they're a musician, they have to be a guitar player. So it's false.
False.
If you're not a guitar player, then you're not a musician.
False.
That's false by the same
What if
reasoning.
they play like drums?
Exactly.
Mandolin.
The last one, if you're not a musician, then you're not a guitar player. I mean, if you don't play anything, you're definitely not playing the guitar. So this is true. Now, one of the interesting things is that the conditional and the contrapositive and the converse and inverse will always have the same truth value. So if the conditional statement is true, the contrapositive should be true as well. And as we see here, since the converse is false, the inverse will also be false. They will always connect to each other.
How is the bottom? If you're not a magician.
Well, if you're not
Oh. Maybe you just want to pick around on it. Not a very good one, but you can.
well, if you're not a guitar player, you're not a guitar.
Exactly.
Well, if you're really anybody that plays at all is still considered to be
Hey,
a musician. I mean,
Magician.
questions on this here?
But anything.
This here is not that bad. It's just tedious because you're just rewriting the same sentence.
15 different types of colors.
Do we want to look at another one of these?
Not really.
No.
Not really.
Do we get how to write these out?
If that's all we're doing,
That is it for today.
is the homework just like that?
Yes. Yep.
No, really, I know.
Yes, I will hand that here. Give that to you here in a second. So, looking at this here, 3 through 6. So 3 through 6, copy the statement, underline the hypothesis, and circle the conclusion. So that's all you're doing for 3 through 6. 7 through 12, so 8, 10, and 12, rewrite the conditional statement in if-then form. 14 and 16, write the negation of the statement. 18, 20, and 22, you're writing the conditional, the converse, the inverse, and the contrapositive, and stating whether it's true or false. And that is it.